Alrighty, so I'm moving on to exercise 2F, which is compound interest. With compound interest, the difference is every interest period you're adding that amount to how much you might owe or how much you might invest. So if you have a look up here, where this part of the example is in your key ideas, it's saying to you that in the first year, if you, let's say, had $100 and it's compounding 10% per year for 2 years. The first year you add 10% onto it, it then becomes $110 at the end of that first year. So that means at the start of your second year, you're now starting at $110. And then you're adding another 10% onto that $110, which then means you're now at $121 at the end of the second year. So whereas simple interest, as it says, it's a lot easier to work with, compound interest has a little bit more of a complexity to it. Now when we look at the formula that is used here in this particular textbook, that's the formula that's given. Now I use a slightly different formula, and this will explain why I'm actually not going to do example 18, because the formula that I like to use looks like this. 1 plus the rate divided by 100 times the little n, bracket times t to the n. Okay, so as you can see, what I've added, and that's different, is this timesing of n here. Basically what that n does is it's how many periods in 1 year would you compound it. And we'll see some questions below how that changes it, okay? So if I were you, this is probably the one that I would be looking at to work with and to have on your page of notes. So all the formulas for simple interest, compound interest, definitely have on your page of notes, because these are normally in the calculator section of tests and exams. So moving away from example 18 and looking at example 19, determine the amount after 5 years of $4,000 and it's compounded annually at 8%. Now this bit of wording here, compounded annually, is really important. That tells you how many times it's been compounded in a year. So I'm going to write my formula out again. A is equal to be the principal, 1 plus r over 100 times my n, and times time multiplied by n. So my principal is $4,000. My rate is 8%. Don't need to change it because it does it for you in the formula. My time is 5 years, and my n, how many times is it being compounded? Well, it's told us that it's been compounded annually, so it's only been compounded once. So I don't really have to worry too much about the n this time. So my principal is 4,000. 1 plus my rate, which is 8%, divided by 100 times 1. You don't need to really write the times 1 because you know what 100 times 1 is. And same goes for 5 times 1. But I'm just writing that in there so that you know where I'm replacing the n. When using your scientific calculator, I recommend tidying up the brackets before you actually do the full calculation. Tidy what you can up, then do the whole lot together, okay, on your calculator, and you should end up with the answer of $5,877.31. 2 decimal places, remember, for money, okay? We won't tell you that. You need to know that. So this is the total, right? And this is the difference between simple interest and compound interest. This is the total. So that's your principal plus your interest that's included in here. Okay. So your interest amount for this actually equates to $1,877.31 because your principal is $4,000, okay? So if you subtract $5,877.31 and you take $4,000 away from that,